think of if I tell you the derivative of something equals f of x. So I'm giving you the derivative function. We call this a differential equation, and the reason we call it a differential equation is because it's an equation that has a derivative in it. And there is a whole branch of mathematics dealing with differential equations. A lot of you, if you're going into some kind of an applied field, might need Math 2250, which is differential equations and linear algebra. Some of you might need Math 2280, which is a full semester of just differential equations. It's preceded the semester before 2270, the linear algebra. So the 2250 is a combo class for kind of applied engineering and those kinds of things, and 2270 and 2280 are two semesters, one for linear algebra, one for differential equations. We're going to have just a little taste of differential equations here. If they give us an initial value or an initial point, a point that this differential equation needs to satisfy, then we call it an initial value problem or an IVP. And remember, when we're finding antiderivatives, there's an infinite number of answers because we have that constant on the end plus c. Now, if you give me an initial condition or an initial value, the function at x naught has to equal y naught, then I can define a unique or specific answer to my differential equation. Find the curve whose slope at the point xy is 3x squared if the curve is required to pass through the point 1, -1. So what we're going to do to solve this is we are going to write a differential equation, we're going to write an initial condition, and then we're going to find the solution. So it says the slope of the curve is this, so that means the derivative is going to be 3x squared. So there's our differential equation. It needs to pass through the point 1, -1, and so that is our initial condition. I can write it like this, or I can write it like this. So now let's figure out what function has a derivative of 3x squared. Well, that function must have been x cubed, but there could be some constant on the end. I don't know what that is. I'm going to use the initial condition to determine what that constant is. So I'm going to take the function and I'm going to put in a 1, and that needs to equal -1. So in solving that, c needs to equal -2. I just subtracted 1 from both sides here. So the solution to my differential equation is the function that has this derivative that passes through this point. That would then be x cubed minus 2. We could confirm that its derivative is 3x squared, and also confirm that when we put 1 in there, we get out -1. Now here is a graph of all of the solutions to that differential equation y equals x cubed, but then what we found was the specific solution that passed through the point 1, -1. So we found this one as the solution for our initial condition or initial value.